Hello everyone and welcome to my channel Chemistry Class. So today we are going to learn what are neutrons and how electrons are distributed in different shells or also called as orbits. In the last class we have discussed about Bohr's atomic model and also I have told you to watch Rutherford's atomic model so that you can understand the concept better. So without wasting further time, let's go right into today's topic, that is neutron, which is a subatomic particle. So in the year 1932, James Chadwick discovered the presence of a neutron in an atom, and mass of the neutron is almost equal to the mass of the proton. And if you ask me what is the mass of neutron, then mass of a neutron is equals to 1.6 into 10 power minus 27 kg, which is also equal to the mass of the proton. And in the year 1919, that means much before when James Chadwick discovered neutron, proton was already discovered in the year 1919 by Ernest Rutherford. And much before when proton and both neutron and proton were discovered, the electron was discovered. That is the first thing. In the year 1897, electron was discovered by J.J. Thomson. So now we have learned three things. When was the electron discovered and by whom? When was the proton discovered and by whom? And when was the neutron discovered and by whom? And though these three, if anyone asks you what are the three subatomic particles of an atom, you have to say proton, neutron and electron. And if you can remember the dates and the names of the scientists, that is well and good. So now we have also known that mass of proton and mass of neutron is the same. So let's see some of the questions in NCERT textbook so that you can understand the concept better and you will be knowing where to apply the concept. So let's see the questions in NCERT. Helium atom has an atomic mass of 4U and 2 protons in its nucleus. How many neutrons does it have? Listen to the question carefully. Helium atom has an atomic mass of 4U and 2 protons in its nucleus. That means the atomic mass of helium is 4U and it has 2 protons in its nucleus. So in the question it is asked that how many neutrons does it have? That means we know the mass and we also know the number of protons. What we need to know? We need to know the number of neutrons. How many neutrons does it have? So let's solve this question. The atomic mass of helium atom is 4U. Whenever you solve a question, before solving a question, you need to write what is given in the question. So in this question, the atomic mass of helium atom is given and the number of protons are also given. How many are the protons in this nucleus? 2. So he is asking simple question, how many neutrons does it have? You know the atomic mass, you know the number of protons. So simply now you have to tell how many neutrons are there. As you all know, mass of an atom is equals to mass of proton plus mass of neutron. So mass of an atom is given 4U is equals to mass of proton, that is 2, and also we need to find the mass of neutrons. Sorry, number of, not mass, number of protons and number of neutrons, and we need to find the number of neutrons because number of protons is already known 2. So number of neutrons is 4U minus 2U is equals to 2. So this is the number of protons. Don't worry about the handwriting, or if you don't understand my handwriting, I have given the clear notes of this entire video in the link given in the description down below. Please save that PDF file to your phone and also read from my notes. From yesterday onwards I am giving the notes for every video, so please go through the notes. So now we have find the solution. let's solve another question. The next question is name three subatomic particles of an atom. What are the three subatomic particles of an atom? I told you just now. They are neutrons, protons and electrons. Yes, exactly. So now we will be learning what were there in the year 1920. In the year 1920, there were only two things, the protons and the electrons, not neutrons. In the year 1920, still it's not discovered, still the neutrons are not discovered, because see, the neutrons are discovered in the year 1932. That means after 12 years, neutron was discovered in the year 1932. So by now you should understand that electron was discovered first and then proton and then the last neutron. So finally in the year 1932 neutron was discovered. You may ask me, proton has positive charge, electron has negative charge, as you all know. Then what is the charge of neutron? Exactly, neutron does not have any charge. It is neutral in charge. So that's what you need to know. And also, if someone asks you, what does the nucleus consist of? What will you say? Will you say protons and electrons, or will you say only protons or only neutrons? Or what will you exactly say? The answer is that the nucleus consists of protons and neutrons. For example, this red color circle is a proton and this is a neutron. They are arranged compactly, that means tightly packed. Both protons and neutrons are tightly packed without any gaps in between them. So that's how protons and neutrons are closely or tightly packed in a nucleus. So by now you should understand that both the protons and neutrons are present in a nucleus of an atom, but not electrons. So now you must be wondering, so where do the electrons present, or where do they live? Outside the nucleus of an atom. Like for example in the concentric rings, we must have seen these three-dimensional rings. The electrons keep on revolving. The circles that I am drawing, these are electrons which are present in the different orbits or shells, you can call them. They keep on revolving, and in the last class also we have discussed that they do not radiate energy, they neither gain energy or not lose energy. So that's why they are always revolving and making the atom highly stable. So now you should understand that neutron, proton and electron are subatomic particles of an atom. Now you can ask me a question, is that you can excite electrons and get them out of the atom. You can so in the same way, why can't we excite a neutron and can we get them out of that atom? Even if you get a neutron out of an atom, it will only stay in a free state for only 15 minutes. That means within 15 minutes it will go and join another atom. That means neutron cannot live independently for longer time. As like electrons, we can excite them and make them come out, but neutrons, it's not like that. Within 15 minutes they search for another atom and then go bind to it. So that is one important property of a neutron you need to remember. So by now we have discussed about protons, neutrons and electrons. Now you must be wondering, I told you that I will be explaining about the arrangement of the electrons around the nucleus. That means the how are they arranged, the electrons, in the shells or orbits. Orbits are also called as shells. Don't confuse with these two names, orbits or shells. They are present around the nucleus of an atom. So how are they arranged? Like what is the representation or what are the rules we need to see now? So arrangement or distribution, you can say. Of electrons in a shell or orbit of an atom. So let's see. For example, the formula that you need to remember while filling the number of electrons is that 2n square. Very important formula, 2n square. So in this formula, the n is equals to 1, n is equals to 2, n is equals to 3, n is equals to 4. These 4 are given. In the last class I told you that these are quantum numbers. That means the values, the integers 1, 2, 3, 4. So now n is equals to 1. That means the shell which is right next to the nucleus of an atom. So 2 into 1 square is equals to 2. So the second shell now, 2 into n, 2 square. What is 2 square? 2 2s are 4, 4 2s are 8. 2 into next one, n is 3. 3 square. 3 3s are 9, 9 2s are 18. Now fourth shell. 2 into 4 square. 4 4s are 16 and 16 2s are 32. So that is the way how these electrons are distributed around the nucleus of an atom in a shell or an orbit. So that's what you need to know. That means by now you must have understood that 2n square is the formula that you need to remember, because n stands for the energy level of the shell number or the energy level. You can call anything, shell number or energy level. N is the shell number or the energy level. Lesser the energy level, closer to the nucleus. More the energy level, farther from the nucleus. So that's what you need to understand. So now let's see how the electrons in the periodic table elements like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, that makes 10 elements. Let's see how the electrons are arranged in the 10 elements in this video. For example, the first one is hydrogen. This is hydrogen, okay? The nucleus of hydrogen. And remember one thing, hydrogen does not have neutrons. Because the atomic number is just 1. The nucleus and then hydrogen is just 1. Coming to helium. Why I have written helium to the right side? Because in the periodic table also, the hydrogen is on the left side and the helium is on the right side. And coming to helium, the nucleus and the first one, this is K shell, which can accommodate 2. Why it can accommodate 2? Because 2 into 1 square is 2. This is K shell. Only 2 are allowed. So helium 2 over. Lithium 1, 2, 3. Why we went to the next shell? Because in the first shell only 2 electrons are allowed, not more than that. So hydrogen, helium, lithium, beryllium. Beryllium's atomic number is 4. So this is the nucleus, the first starting 2, so another 2 more. The second shell. So that's how we do. Hydrogen, helium, lithium, beryllium. Okay, I'll write boron here. Boron is 5. Nucleus, first shell 2. Second shell, 3 are allowed, right? Yes, they are allowed. Because 2 into 2 square, 4, 4 2 is 8. 8 are allowed in the second one. So boron, hydrogen, helium, lithium, beryllium, boron, carbon. What is carbon? 6. 1, 2, 3, 4, 5, 6. Actually, I can write these circles with red so that you can understand better. So 1, 2, 3, 4, 5, 6 carbon over. Let's see the nitrogen, oxygen, fluorine, neon. Nitrogen 7 atomic number. 1, 2, 3, 4, 5, 6, 7. Okay, sorry. You can see 7 electrons are present here. 1, 2, 3, 4, 5, 6, 7. So coming to oxygen, 8. 8, right? So in the first one 2. So 6 more are needed. 1, 2, 3, 4, 5, 6. So coming to neon, oxygen, fluorine. Fluorine is 9. So 9 means the starting shell 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Outermost 7. Actually outermost only 8 are allowed. So coming to fluorine, neon. So in this, exactly everything is filled. 1, 2, 3, 4, 5, 6, 7, 8. Outermost 8 are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 are completely filled. So in this video we have discussed about the order or the arrangement or the distribution of the electrons in the atoms of the periodic table, in the elements of the periodic table. Like hydrogen to neon, there are 10 elements. So in the next classes we will be discussing about more elements. So for this class we have discussed about hydrogen to neon. So let's see some questions again. Write the distribution of electrons in carbon and sodium atoms. In carbon atom I have written, we have seen that, but in sodium atom I did not write. That is the atomic number 11. This is the 11th element present in the sodium, is the 11th element present in the periodic table. So let's see what we have to write in sodium. Sodium atom, that is 11. So again nucleus, circle, don't call it circle, it is shell. You will also understand why I have drawn 3 shells, because starting 2 are allowed. 2n square, right? 2 into 1 square, 2. 2n square, 2 into 2 square, 8. 2n square, 3 3s are 9, 9 2s are 18. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Second one 8 are allowed. So 8. First one 2 are allowed. 2. But still we need another one. So that's why we are going to the M shell. This is K shell. This is L shell. This is M shell. M shell 18 are allowed, but we just need only another one. So just another one. So this is how we draw sodium. So let's see another question. If K and L shells of an atom are full, then what would be the total number of electrons in the atom? What they are saying here is that the K and L shells of an atom are full. That means, for example, you take this. The K shell, it is full, only 2 are allowed. And the L shell, it is full, only 8 are allowed. Then what would be the number of electrons in that atom? They are asking the number of electrons when the K and L shells are completely filled. So let's see. Now. K plus L shell, 2 plus 8, total 10 electrons. Just add them up. If someone asks you what is the total number of electrons, just you need to add them up. The K and L shell. K 2 are there and L 8 are there. So 8 plus 2, 10 electrons. So that's what we have discussed. A small recap, we have discussed about the persons who discovered neutron, electron, proton. We have came to know about the subatomic particles. We have discussed about the neutrons lifetime when being independent. We have also discussed about the shells, the formula, and also the arrangement or distribution in this class. So until next class, we will be learning this, and also we will be learning about valency in the next class. So in the next class we will be learning valency. For that also same, the notes also will be given same like this class. And if you have any doubts, you can ask me in the comment section down below. Please don't forget to subscribe to my channel, and if you like the video, then please like the video. If you did not like this video, then just please tell what you did not understand in this video. I'll again explain in the next class. Thank you very much.